Hello guys, Ancient Gameplays, I'm Fabio Pisco and welcome to my channel.
Yeah, boy!
You guys know that I don't really do some news videos, and I do mostly regarding to the technologies that I test a lot, like AFMF, lossless scaling and so on, and usually I make those videos about the news, when there are some really interesting news. As for today, I'm kinda mashing it up with lots of news that we have, lots of interesting news regarding AMD, Intel XeSS multi-frame generation, XeSS3, so on. So lots of things packed in this video, and we're gonna read the news from video cards today, because it's easier for me to read the news and then give you some input on those same news. Firstly, we start with AMD Instinct MI400 series, with 2nm XCD dies. Now this is important for one reason, because according to this, it seems that AMD is the first one to use 2nm dies for their CPUs or GPUs. And in this case scenario, we've been seeing NVIDIA for years and years using the lithography, the newest lithography first. So if TSMC goes with 1nm, NVIDIA used to use that 1nm first, and so on. I believe that the only time that NVIDIA was kind of behind was with the RTX 4000 series, the first batch of the RTX 4000 series, since they used Samsung's 8nm technology instead of TSMC's 7nm. I believe it was something like that. So in that regard, NVIDIA was behind, but usually they are always in front. During an interview with Yahoo Finance, AMD CEO Lisa Su confirmed that the company's next generation data center GPU, the Instinct MI450, will be its first accelerator to use 2nm process technology. The new architecture is set to launch next year. The interview followed AMD and OpenAI's announcement of a new partnership, which will see OpenAI deploying MI450 chips next year. And again, this might not seem really relevant, but it is, because if AMD already has some contract to use TSMC's 2nm lithography, it means that they actually might have 2nm first on their CPUs and GPUs. The same way that you might have today's sponsor first. Today's video sponsor is GVG Mall, bringing you lots of software deals like Windows 10, Windows 11, Office 2019 or 2021 with a new Windows 11 design, and for all of these you can use my SKG discount code for 30% off, getting a Windows 11 serial key for $22 and a Windows 10 one for only $15. Then use the key on your Windows settings and you'll have an activated system. Next we move to Intel updates, and we have some really interesting things on the GPU roadmap. Now this is a bit confusing and I wouldn't make it this way, but well, we have the Xe architecture, which features the A series GPUs like the A580, the A750 and the A770 discrete GPUs, Intel Arc GPUs, and then we have Meteor Lake and Arrow Lake CPUs with Xe iGPUs inside. Now, it is a bit strange because, for example, Lunar Lake is still using Intel Arc graphics, but at the same time they say it's using the Xe2 architecture. As for the B series, we have the Battle Mage discrete graphics, again, the Pro GPUs that Intel released right now, the B570 and the B580, that's what we have right now. And then we have Panther Lake CPUs with integrated graphics, but now instead of the Xe2 series or the Xe2 architecture, we have the Xe3 architecture, meaning that the Panther Lake CPUs do have, or APUs do have, integrated graphics with the Intel Arc B series, and even though they're B series, they're not using the Xe2 architecture, which is from the B series, they're using the Xe3 architecture, which is completely messed up. I mean, people complain about nomenclatures all the time, but this is just crazy. And then we have the Xe3P, which will be the next series, most likely the C series. And what I wanted to show you here was this part with Xe3P and Nova Lake AX rumors. The newly shown Xe3P has already appeared in recent leaks tied to a high-performance SoC known as Nova Lake AX, reportedly designed to compete with AMD's Strix Halo and Apple's M series. Accordingly to well-known leakers, Nova Lake AX would combine 28 CPU cores with 8 performance cores, 16 E-cores, which are the efficiency cores, and then we have 4 LP, which I suppose means low power cores. So, I mean, Intel is really digging a hole here, because if they make it work, it will be great. But I mean, they are combining several different architectures inside the same CPU. So they have 8 performance cores, which are from one architecture, one CPU architecture. Then they use 16 efficiency cores, which run on another architecture, from what I know. And then 4 low power cores that use even less power than the efficiency cores. And they will most likely run on another architecture. I hope not, because it will be a completely mess up, but maybe they will, so I don't really know. If they do, Intel is digging a hole. Then we have integrated Xe3P GPU with 384 EUs, which are 48 Xe3 cores. For perspective, if we go into the B580, we can see, or let me just see the amount of Xe cores that it has. We do have the XMX cores 160, which is not here. In terms of RT cores, we have 20, and then we have execution units, also 20. So AMD went bananas, went nuts, and they went with Ryzen AI Max series, and they are going up to 40 compute units of RDNA 3.5, meaning that the GPU that you have inside your APU at 120 watts max power draw, or in some case scenarios 140, you can go with, let's say, RX 7600 XT performance in most cases inside an APU with much less power, with a CPU and GPU together. So that's a huge breakthrough in terms of APUs. Now, considering that the Intel Arc B580 actually has 20 execution units, so 20 Xe cores, and we have things like the RX 7600 XT that only have 32, I believe, and still the B580 performs considerably better, even though it's a newer generation and so on, but it still performs considerably better when the architecture is actually put to work. I believe that if the Xe3 architecture gets to be actually good, with 48 Xe cores, it will definitely outperform the 40 compute units of RDNA 3.5. Then AMD will have to come with RDNA 4 and so on, so on, so on. But that's the game. And as for the memory bus, we also have 256-bit of LPDDR5X memory bus, supporting up to 10,667 mega transfers per second. Competition is always great, and these chips are really expensive, so I do hope that more and more of them start coming, so we do have way more powerful integrated graphics, so we have more competition, so we have reduced prices. And as soon as we start getting more and more powerful iGPUs, the discrete GPUs will have to ramp up in performance as well, otherwise they won't sell. So it's a win-win situation in most scenarios. And the next news is really great for people that are looking into frame generation. Intel announces XeSS 3 with XeSS multi-frame generation, MFG. At the Intel Tech Tour, the company officially announced XeSS 3, the next major version of its AI-based upscaling technology. A new feature called XeSS MFG, multi-frame generation, was also introduced, expanding XeSS beyond traditional single-frame interpolation. According to Intel, XeSS MFG will become a core part of XeSS 3 stack and is designed to generate multiple intermediate frames for smoother animation and higher perceived frame rates. And this is a really good thing, because they're not talking about FPS, they're not talking about increased FPS, they're talking about smoother animation, since we're talking about more FPS per se, so more FPS equals more hertz, so we have smoother animations and higher perceived frame rates. Because of course you have higher frame rates, but at the same time the latency is not lower really, but you do have more FPS, so if you have a high refresh rate panel, you can actually take advantage of those higher FPS, which will give you smoother animations and again, higher perceived frame rates. This is a similar approach to NVIDIA's DLSS stack, which separates upscaling and frame generation. By the way, AMD already does that already, they separate frame generation and upscaling. With XeSS 2, Intel included frame generation, so the next step is multi-frame interpolation, capable of generating up to 4 frames from 2 source frames. XeSS MFG uses an optical flow network built on motion vectors and depth buffers, interpolating 3 additional frames for up to 4 times frame output. And if we look at the image, we can see the full resolution frame renders, the previous and the new one, and then we have motion vectors and depth vectors, and this will go into the optical flow reprojection, which NVIDIA calls optical flow accelerator, optical flow accelerators, sorry, OFA, and then we have the motion vector reprojection, and then we have the blend going up to 3 interpolated frames. Frame generation is kind of guessed frames, but the better they're guessed, the more quality you'll have. And that's where AI comes in and so on, in order to kind of guess those frames better, to kind of predict those frames better. And that's why the new machine learning techniques in terms of frame generation are much better, because instead of using only the software, they're using AI to predict it, and the prediction of AI is much more accurate. So that's how it goes. With this release, Intel becomes the second GPU vendor to support multi-frame generation, following NVIDIA's DLSS4, which is correct. We don't really know yet if FSR Redstone will have MFG or not. We just know that it will have machine learning frame generation. However, unlike the DLSS4, XeSS3 MFG will support all ARC GPUs with XMX hardware, including the ARC A series, Core Ultra 200 Xe2, and future ARC B series Xe3 products. Older Xe1 GPUs will also get support later, making Intel the first to bring multi-frame generation to multiple generations of hardware. If you don't count lossless scaling, of course. Intel also confirmed new control options coming to its graphics software app. The frame generation override feature will let users manually select 2 times, 3 times, or 4 times mode, or leave it to the application. The same update adds shared GPU/NPU memory override, allowing users to allocate system memory for iGPU and NPU workloads, similar to AMD's shared memory feature, which is great. So if you are using an Intel APU or GPU, you can actually go with shared GPU/NPU memory override. If you are doing lots of AI workloads that you can use your NPU with, you can just go and add more system memory to the NPU in order to have better AI performance, which is great. And now we have more slides with XeSS2 upscaling and frame generation that we had before, native, and then XeSS2, and then we have here the FP instructions, int instructions, XMX instructions. If you are running XeSS on a non-Intel card, it will use int instructions, but if you are using it with an Intel card, it will use the XMX ones. It's basically the same that we have now on the AMD side, with the leaked int8 FSR4 and the FP8 FSR4. FP8 FSR4 performs better, delivers better image quality, but the int8 works with older cards, and the same applies for XeSS, that works with older cards with the int model, but it works considerably better in terms of quality and performance with the XMX one. And this is basically what we have here. The super resolution enters here and kind of overrides the need for the denoiser, since the super resolution works as denoiser. So we just have mirrors and deferred back then we have denoiser with the super resolution and frame generation going to the optical flow. So it's basically what it does, meaning that overall you get more performance because the pipeline is not as full as it was before with TAA, denoisers, and so on. And remember the video I made a couple of weeks ago telling about the shader compilation issues that were going to get fixed, and AMD was the first one supporting them because AMD had hardware on the ROG LIX, the handheld device. Well, Intel is talking about that now as well. The company also outlined upcoming shader pre-compilation support through Microsoft Advanced Shader Delivery System. This will allow Intel's drivers to download pre-compiled shaders from the cloud, reducing first launch stutter and improving loading times. So basically, when you download the game, you can go to the drivers and they will also download pre-compiled shaders. So when you go into the game for the first time, you don't really have those huge stutters that you see every time you go into games that don't pre-compile the shaders. Games like, let's say, PUBG. If you go into PUBG, it doesn't really pre-compile shaders, so the first time you go into the game, especially if your CPU and disk are slower, you will have those stutters. And there are many more games like, let's say, the older, especially Unreal Engine 5 games, some Unreal Engine 5 games, you have lots of stutters the first time you go in. Same for Unreal Engine 4 games like, let's say, the first Berserker Kazan. The first time I go into a new area, I have lots of stutters. After that, it is smooth. But the first time I go in, I have lots of stutters, and that's why we have this, the pre-compiled shader distribution, meaning that the first time you go into the game, you kind of have a stock package of shaders pre-compiled, and the stutters will be much less, which is great to be honest. And if you are one of those guys that use PresentMon a lot instead of using MS Afterburner or RTSS, you can now know that PresentMon will be updated to support MFG, showing both native and generated frame metrics. Intel also introduced Intelligent Bias Control v3, improving GPU scheduling and power delivery on upcoming Panther Lake SoCs. Now this is the most important part because Intel hasn't confirmed the release date for XeSS3 or the new control features, but both are expected to debut with Panther Lake platform and Xe graphics architecture in 2026. Now we already have MFG on the Nvidia side, and we know that we're going to have Redstone at least by the end of 2025, so a couple of months in the future, I suppose. So yeah, we're most likely going to get AMD's technology first, and maybe they will deliver MFG, but still it's great to see that Intel isn't going down on the features and they're trying to keep up and maybe sometimes innovate in some case scenarios. Again, competition is always great. And we talked about Panther Lake before in the previous news, of course, and now we have some news about the performance, or at least some, I wouldn't say leaks, because these are Intel slides and we should all take these with a grain of salt, the same for AMD and Nvidia. But well, let's just follow the trend and see where it goes. Intel Panther Lake with up to 12 Xe3 cores, which is not bad again. 12 Xe3 cores would most likely fight with the Ryzen AI Ajax series, and according to Intel, they improved the performance by more than 50%, and they also improved over 40% the performance per watt compared to Arrow Lake H. And if you want to see, they also have some slides about the Xe3 architecture optimized from engine to slice for a more consistent experience. That's what I hope, because Xe1 and Xe2, they were plagued with several issues, especially the CPU overhead ones, which are not only software-sided but also hardware-sided, so I really hope that with Xe3 they kind of fix that. We have all the details here with enhanced ray tracing units, of course, BVH, then we have the Xe Vector engine, up to 25% more threads, variable register allocation, and FP8 dequantization support. So they now support the FP8, which is also great, and with also enhanced GFX fixed function, with new Herb Manager, up to 2 times anisotropic filtering, and up to 2 times the performance as well in stencil test rate. But we do have some more images here. Panther Lake micro benchmarks with vertex rate, color blend, GMMEs. This is just micro benchmarks, this is not reality. This may not and will most likely not translate to real world, but we do have some real world performance benchmarks with 3D Mark Steel Nomad, Cyberpunk 2077 ray tracing, Cyberpunk 2077 ray tracing with XeSS, and Black Myth Wukong. And in terms of traffic reduction on SoC Fabric, we have 17% less on Steel Nomad, 19% less on Cyberpunk, with XeSS 27% less, and on Black Myth Wukong 36% less. And if we have way less traffic on SoC, it means that the CPU overhead might be getting fixed. Meaning that in some titles where we had huge CPU overheads, we might be actually getting decent performance now, and that's very good news. In terms of integrated graphics, we have 2 configurations. We have the one with 4 Xe cores and the other one with 12 Xe cores. So I don't really know if these are the 2 APU variants, or if this one will go to the CPU side and this one will go to the APU side. Either way, 12 Xe cores with 96 XMX engines is actually a decent performance for an APU, and I'll be sure to be testing it if I get the chance. Thank God. Now let's move to the AMD side, which also has very interesting news. AMD and Sony discuss Project Amethyst, which is PlayStation 6 and next generation RDNA GPU technologies, and there are lots of technologies and things that Tom from Moore's Law is Dead actually talked about PS6 and so on, and we have these here with a video done by Sony's Interactive and AMD's Jack Yoon. And if you want to see the video, you can see the video here. It is on YouTube on AMD's channel, so you can go there and see it. And by now we know that RDNA 5 will be inside the next PlayStation, the PlayStation 6. With RDNA 4 and FSR Redstone, we are already getting some very interesting things like neural radiance caching, some compression things and so on, but this is taking these steps forward for RDNA 5, and Tom from Moore's Law is Dead already told us that we do have some really interesting features with RDNA 5, and that the ray tracing performance will be massively improved, and of course that it would be inside PlayStation 6, and it was right. AMD and Sony Interactive Entertainment have already announced Project Amethyst, a long-term collaboration focused on integrating AI and machine learning into the future gaming hardware and software. The partnership, symbolized by the merging of AMD's Red and PlayStation's Blue, hence Amethyst, aims to develop foundational AI systems for both PC and PlayStation platforms. So the news that you see here are not only for the PlayStation hardware, but also for the discrete graphics hardware, and maybe, of course, integrated graphics hardware. In the short term, both companies are co-developing neural network architectures and training strategies optimized for game graphics, work that already contributed to AMD's FidelFX Super Resolution 4. Mark Cerny confirmed that FSR4 will be re-implemented on the PlayStation 5 Pro to take advantage of the new AI acceleration hardware, meaning that yes, guys, you were having the PSSR, and PSSR was basically kind of a beta version of FSR4, I would say, a very early version of FSR4, and now you are going to have FSR4 inside PlayStation, which is a major uplift, believe me, a major uplift in terms of quality. Over the long term, the collaboration will extend to designing new hardware architectures for machine learning workloads, influencing upcoming AMD GPUs and Sony consoles, including, of course, PlayStation 6, which name is not confirmed, but we all know it is. Yeah. Then we have some slides with the next generation AMD gaming technologies. Again, this is an early technical preview, and like Jack Wynn says, this is some years in the future, but at least we know that they are working on it. Starting with Neural Arrays Performance, a collection of compute units connected to share and process data to work together like a single AI engine. So compute units will do the work for AI, designed to be more efficient on larger ML workloads and benefit neural rendering, which is great. Then we have the Radeon Cores Immersion, new dedicated ray traversal hardware to deliver high-performance real-time ray tracing and path tracing. Frees up shader cores to work on the rest of the scene, resulting in higher FPS with immersive visuals. Again, Tom from Moore's Law is Dead said that the ray tracing performance on RDNA 5 would be a huge uplift compared to RDNA 4. There was already a huge uplift compared to RDNA 3, and it seems he was right. Then we have Universal Compression Efficiency, a new system that evaluates and compresses all available data within the GPU to dramatically reduce memory bandwidth usage, enables new level of performance with greater efficiency. So again, compression techniques. And then we have more slides for the neural arrays, for the Radeon Cores, and then the universal compression, which is a really interesting thing. Let's hear a bit about it on the video itself. So let's go.
Requiring significantly more bandwidth to handle 4K plus textures and ray tracing denoising masks for smooth asset streaming. And that's where a final piece of news comes in, and yeah, it's a big one.
With current GPUs, including the ones in PlayStation 5 and PlayStation 5 Pro, we have something called DCC, or Delta Color Compression. It's a strategy that reduces the memory bandwidth consumed when the GPU is reading or writing certain data, such as textures or render targets.
And what we've built for future GPUs and SoCs take the idea of data compression much further. We call it universal compression. It's a system that evaluates every piece of data headed to memory, not just textures, and compresses it whenever possible. Only the essential bytes are sent out, which dramatically reduces memory bandwidth usage. That means the GPU can deliver more detail, higher frame rates, and greater efficiency.
Here too,
Basically that's it. Instead of just using the color information, it uses basically almost every information, delivering just the minimal that they can to the GPU in order to reduce the needed bandwidth by a lot.
Really looking forward to what improvements universal compression
I'm looking
will bring.
forward as well in a couple of years. And the last news is just going a bit to Intel about XeSS3. Intel XeSS3 dropping to all games with no changes to the API. Basically, if you have a game with XeSS2, XeSS3 will basically be there, meaning that if not through the game, through the software, you can use multi-frame generation in a game that supports XeSS2, meaning that supports XeSS2 upscaling and frame generation. So if the game supports XeSS frame generation, it will support XeSS MFG. And if you want to watch it all, you can go to Intel's technology channel, and you have a video, 2 minutes 41, so it's a really small video, and it brings some really interesting things, some interesting features. And well guys, that's all for today's video, just me reading some news and giving my input in between. Hope you enjoyed the video, thank you very much for watching, and guys, see you in the next one, because the next week we're gonna have some very interesting videos, so stay tuned.